Hi everyone, this is your struggling CS student, and let's take a look at today's problem of the day. Alright, so today's problem 2270, number of ways to split array. Okay, so you're given a zero index integer array nums of length n. Okay, nums contains a valid split and index I if the following are true. The sum of the first I plus 1 elements is greater than or equal to the sum of the last n minus 1 elements. And there's at least one element to the right of I that is 0 less than or equals to I less than n minus 1. Then the number of valid splits in nums. Okay, there are three ways of splitting nums into two non-empty parts. You can split at index 0, and the first part is 10, and its sum is 10. And the second part is its sum is 3. Okay, so 7 plus 4, 11 minus 8, which is 3. Split nums at index 1, split nums at index 2. Let's take a look at example 2. Example 2, there are two valid splits, split index 1 or split index 2. Okay, the constraints are 10 to the power 5 for nums dot length, and okay, nums of y is within this number range. So I think, if you have been solving the problem of the day consistently, then you recognize that this is similar to the problem yesterday, where the idea of a prefix sum allows you to find the sum of the subarray in constant time. And I think as long as we can build the prefix sum, we are able to essentially calculate the sum of two subarrays. And whenever we consider like a particular index, we can do a split and we can check if the condition is being met. So I can just do a quick draw. So suppose we have a few elements, let's say A, B, C, D, doesn't matter what number is. Then we can build the prefix sum like this, and maybe, yeah, ABCD is not a good example. Let's just do for, say, 1 and 7, right? Then if we build the prefix sum, it will be 2, 6, 7, 14. Then once we build the prefix sum, we can just perform a split at every index. Let's say at index 0, we can do a split here, and at index 1, we can do a split here, and then we can just compute, for example, the sum of a particular subarray and ensure that the left side is greater than the right side, something like that. Yeah, so you just compare like this and compare like this, compare like this, and you're done. There's no point, there isn't a point where because you need to have non-empty subarrays. So I think we can just do just that. Oh, sorry about that. Yeah, okay, so let's get on with it. So initially the nums of 0 prefix sum, that are we guaranteed to have at least one element, or we're guaranteed to have at least two? Yeah, okay, fine. So for I in range of length of nums, starting from index 1, prefix sum dot n, prefix sum of -1 plus nums of I. And from here, for I in range till length of nums -1, here the left side you can say is prefix sum of I minus, so the left side is just a prefix sum of I. Yep, then the right side is equals to prefix sum of last element minus. So we want to exclude this, so we will be minus prefix sum of I. This will give us the right side. And we say if the left side is greater than or equals to, is that what they want? Greater than or equals to right side. Then we can do the count plus equals 1, right? Count is equals to 0, return count. Okay, let's give a dry run. Oh, I see. We're going to initialize a list, or it's a typo rather. Okay, passes a sample test case. I'm quite confident that this will probably pass all the test cases. But what about the empty case? Maybe like, what if it's like this? Do I do the count then? Yeah, we have at least one count. Okay, I see. All right, yeah, I think this will work. So let's take a look. Let's analyze the time and the space complexity. The time complexity, well, is just going to be O(n), where n is the number of elements in the nums array. And then the size, or the space complexity rather, is also O(n), where n is the number of elements in the nums array. Because we built the prefix sum here, this takes O(n) space. And yeah, building the prefix sum itself also takes O(n) time. And then when we count the number of ways to split the array, then this, as we are only iterating through the nums array, this also takes O(n) time. So the time and space complexity are both O(n), where n is the number of elements in the nums array. So let's give it a submit, and hopefully I didn't make any mistakes. Okay, so we get accepted. We get a completion streak of 8 days. So let's take a look at the editorial and see what they have to say. Usually they bunch questions up together. So, yesterday is perfect sum, today is perfect sum. Maybe tomorrow is perfect sum or another topic altogether. Right, but let me just reset this code and put the submission on the right, this. Now let's see what LeetCode has to say about the time and space complexity. I think it's fairly straightforward in this case. Yep, and this is the solution. Like so, okay, editorial. Perfect sum array, or there's optimized prefix and suffix sum. I see, okay. Yeah. Technically, you do not need the prefix sum. Okay, so the idea here is you realize that you don't even actually need to build the prefix sum. What they're saying is essentially as you iterate through, you can already how should I say? Oh, you still need two pass, right? Do you need two pass? Oh no, you don't need two pass. Oh, okay, you don't need two pass because they're moving it from the right side to the left. Okay. Initially, I was thinking like you do a two pass. So the first pass from the left to the right, you get the total sum of the subarray, and then you do a second pass from left to right again. But this time around, you keep track of the left side. You keep track of the left sum. But then since you already have the total sum, you can just deduct off from the left sum, and then you can compare whether the left sum is greater than or equals to the right sum. Okay, yeah, technically you do not need to maintain the prefix sum in this case, and you can optimize this to get O(1) space complexity. But yeah, okay, that's all for me today. Thanks for watching, and happy grinding.